Okay, let's continue. So yesterday we introduced for the attach procedure. It's divided into 4 parts. Yes, can you remember the 4 parts?
Yes.
Yeah, for RC connection and S1 connection and active the AS security and then create the barrier. As well as now you can remember it. Yes. And so you will know the normal procedure. So when you match an abnormal, you will solve it. So yesterday we introduced the RC connection. We introduced two signaling. One is RC connection request and the RC connection setup. So in the RC connection request, it contains 2 useful information. One is for the UEID, who am I? Yes, UEID. Another is cost, establishment cost. Why I connected with you? Yes, one is who, one is what. Yeah. So these 2 information. So for the UEID, we have 2 kinds. One is that if it has the Optim say, it will use Optim say for the UEID. Maybe it's the first time attached. So there is no Optim say, so it will use another value. And for the cost, we have 5. We have 5 kinds. For the useful, we usually use is 3. The MO signaling, MO data, and the MT access. So now for the area for the attach is MO signaling like this. And we said when the node receives this request, okay, it will decide if I have enough resource, I can permit you access to it. So I need to tell you how to configure. Yes, how to configure this RC connection. So for the create this RC connection, yesterday we introduced for such as the MAC layer, the physical, the RC layer, the PTP layer, like this. All these parameters is the cell parameter. So under this cell, all the UE, the parameters are same. Under the cell, the parameters are same. Now in the RC connection setup, its main function is to let the UE to create the SRB1. Yeah, so it contains the RB1 configuration. Yesterday we introduced, okay, all these parameters, it relates to the SRB1. So how to create this SRB1, its configuration. It relates mainly the RC, the mic, the scheduling, and such as the BSR, the PHR, like this. And yesterday we introduced at the PHR config. Yeah, I said the PHR is that it relates to the power. The power has to report. So for the power is that the UE will give it a maximum value to transmit. It's 23 dBm. The maximum power it can use is 23 dBm. But maybe we calculate the UE use the power control. It will calculate based on the path loss, based on the RB number we allocated, based on the MCS. It will calculate one serial power. So it will compare these two. So maybe this PHR is minus value. If it's minus value, that means, okay, actually I need with I use are different, and actually I need is greater than I really transmit. So I only have 23, maybe you need use 30. That means for the uplink, maybe we have some interference. Maybe the carriage is weak. It can help us to decide how about the uplink carriage. So for the PHR, the report, it has 2 kinds. One is the period. Another is based on the event. For the period, it will define a timer that how long you need to report the PHR. So it's 1,000 subframe, that's 1,000 milliseconds. As 1,000 milliseconds, every 1,000 milliseconds, you need report it. You need report it. And for the prohibit PHR timer, that is, okay, once I report this, during this time you cannot report. You cannot report. Okay, we set it here is 0. That means, okay, never prohibited. Yes. So the downlink pass loss change. Downlink pass loss change. So this is for that. The first timer is for the periodic. So if every 10,000 milliseconds, I will report 1. But based on event, we will based on the pass loss change. So if the pass loss change greater than this value, I will report. I will not wait for this value. Wait for the 1,000 milliseconds. So this is for the PHR. And next is the physical parameters for the how to configure the PDSCH and how to configure the POSCH, how to configure the power control strategy, like this, and the antenna info, and the scheduling request configure, how to transmit the scheduling request. Now for the PDSCH, we know in our power control parameter, we have the PA/PB like this. Tomorrow we will introduce what is PA, what is PB, and how to control it. So you will know, okay, here we have this parameter. In the RC connection setup, we have this, the PA. What is PA? The PA is 3 dB. You can check your PA, what is PA. Yeah, tomorrow we will introduce what is PA, but now you also know, okay, the PA is delivered in RC connection setup. In RC connection setup. So next time, if you when you choose the signaling, you want to check this cell's power control strategy. You want to check SPA, you know here. It in the RC connection setup and RC connection setup. So it's in the RC connection setup. Even all the cells. Under the cells, all the UE is the same value, but we can see that this is a UE level parameter because we use RC signaling. If the parameter is a cell level parameter, we will broadcast it by the SIPs. So even all the UE use the same value, but actually it's the UE level value. So we will use RC connection set up to deliver it. But here we only see the PA, there is no PB. That means the PB is not the UE level parameter, so it will not use RC signaling to tell the UE. It will use the system information to tell the UE. These two parameters are different. So when you see our parameter, you see is the UE level or the cell level. It relates to the UE receive it by the RC signaling or by the broadcast information. Now this is for the POSCH configure. How many the arc bit offset. This is also for some common because for the arc, for the RI, for CQI, this information, this control information, we can transmit it by the PUCCH. Also, we can transmit by the POSCH. Yeah. So if we have POSCH, we will use POSCH to transmit it. If we don't have POSCH, we can use PUCCH. So it's configured in the POSCH. And for uplink power control parameters, this is power control parameters and how to report the CQI. Yeah, it's every 30 milli. Not what is RI? Let me check. Remote. RI. Okay, I need to check this unit. In the break, I will check it. I will first skip it. And the antenna info, how many antennas the UE. Here the transmission mode is used transmission mode 2. Transmission mode 2 is what? What is the transmission mode? The transmission mode we totally have 8. Transmission mode 1 is used single antenna port. Transmission mode 2 is the diversity transmission. It's diversity. Transmission 3 is multiplexed like this. So here is select the UE when you receive the signaling for SRB1 signaling. If the signaling are transmitted by SRB1, you should use the transmission mode 2 to receive it. So that is a diversity. Yeah. And for the scheduling, it configure how many SR you can use. Yeah. So this is in the RC connection setup. So it relates to the SRB1. So for the RC connection, the last signaling is RC connection setup complete. We know this is we tell the node B side, I finished configure the SRB1. I finished the RC connection. So I tell you I complete this. And also we have the NAS signaling. I need to transmit to MME, so it will contain the NAS signaling. So let's we check the RC connection setup. So in the RC connection setup, it contains the selected PLMN. When we perform the cell selection, we will first perform the PLMN selection with the UE powered on. It searches the cells, and then when it selects a cell, it first selects a network. Because your cell phone, under this area, there are many different networks. It's not only a smartphone, it also have others. And for smartphone, now we only have LTE. But before we also have the CDMA. Yes, we have different networks and we have different operators. So in node B, the UE, the SIM card, it have a home PLMN. So it will register to a proper PLMN. So it will first select it. So it will tell the node B, the select PLMN. So the select PLMN, it contains the it is used the identity to indicate it. One, that is, I have a PLMN list. I select the first one, PLMN, and I register MME. The register MME is the MME group ID and the MME code ID. So the node B will find this MME to deliver the information. And dedicated in for NAS, this is NAS PDO. So the node B will not decode this NAS PDO. He will deliver this NAS PDO to this MME directly. So we cannot decode it. Mm-hmm. So it will contain the, if you have decoder. How many do you have the decoder?
I don't have Wireshark.
You don't have Wireshark. I also don't have Wireshark because we're forbidden to install Wireshark. So I don't use decoder. So I cannot show the NAS PDO to you. But we know here is dedicated for the MME side. So we can see in the RC connection setup complete, it contains the important information is that one, which PLMN I select, and which MME I select, and my information for MME. Because this is I want to register on the MME, so I need to tell MME what's my information. So in the NAS, it contains the attached request. attach request, and accept the attach request, and it also have a PDN connectivity request. So I not only register on MME and also create the barrier. If you permit create the connection, so that means you permit me to create this barrier. So it also contains that. And it will also contain some old information, for example, the old GUT. So this is the first time I attach, but before, maybe I powered off on other area. I will have the old GUT, yeah, this information. So this is the RC connection complete. So when the inode B received the RC connection complete, that means this is one RC connection user. The RC connection is have already. So we will have some different counters: the active user, and the RC connection user, and the maximum RC connection user. So for maximum RC connection user is related to the inode B capability. Yes, for different cells, you buy a different license, you will get a different capacity. So this is one. So this is only related to the hardware capacity. So except this, we also will calculate, will count the, for example, every time the active RC connection user. So even we at RC connection state, now it's at RC connection state, but you cannot do service. Yes, you cannot do service. So you will see, except this RC connection, you also will have the user plan, the active state, the active connection for user plan. So that means you have already created the barrier. Now it's only create the RC connection. So this is the first part. We have finished the RC connection. Next, we need to create the S1. Yes? The S1. So when we create the S1 connection, is that the inode B send the UE message, to the network, to the MME. Yeah, send the UE message. So here, because when we trace the signaling, it may be generate an error in the time sequence. Actually, the UE capability inquiry is later than the initial message. Is later than it. Okay. So in the initial UE message, we can see the initial UE message. It will tell the MME side. Tell the MME side who is the UE. So it contains inode B UE S1 AP ID. So now we want to create this connection. For the UE and the inode B, because it's 1 I don't need to give it a connection ID. But for the S1, under inode B, there are many UE. Under the MME also have many UE. So we need to use the ID to indicate this connection belongs to which UE. So for this connection, we have two ends. At the inode B end, the inode B will generate one ID. At the MME end, the MME will generate ID. So when the inode B generates, okay, now inode B generates the ID is 18156. Okay, I generate it and I will send to MME. You also will generate one. Okay, these two will be one pair. Because these two ID is generated by two different hardware. So it may be different, maybe same. Maybe different, maybe same. So it can be same, it can be different. It doesn't matter. So this is this ID. So except this ID, I need to send the MME the NAS PDU from the UE side. Yes, it should contain the NAS PDU. So except the NAS PDU, I also need to send the TAI. That is, we know the TA is the UE location. Is to indicate the UE location. So we need to tell the MME where is the UE, because when the MME send the paging to the inode B, it's based on the TA. It's based on the TA. When the UE at the other state, we don't know where is the UE. We only know the UE at which TA. We don't know exactly which exact inode B. So we should tell the MME, now I'm the TAI. Now I'm the TAI. So for the TAI, for this TAI, it should contain two parts, PLN and the tag. It contains two parts, PLMN and the tag. Yeah, this is so every cell it will have a TAI. So when the UE sends the ARS connection request to the inode B will know, okay, this cell's TA. So it will report to the MME. So the MME will register it, will save this location. The TAI, it contains the PLMN. The PLMN, it contains two parts, the MNC and the MCC, the country code and the network code. So here is 14F015. So how to read it? Is the F is divided by this F. Actually, it should here it should be reverse it. So it should be 410, like this, and 51. So this is PLMN, and for the tag, the tag is this value. So next is ECGR. ECGR is the tag is only indicates the area. This tag area, it contains many cells. So which cell I'm staying in is this, the ECGR. The ECGR, it contains three parts. One is PLMN at which network. The ECGR is the unique indication for one cell. So for unique, it's at which network and under which inode B. Under this inode B, which cell, like this. So usually we will call the inode B ID as the cell ID is the cell ID. Yeah, PLN we have already got it. So next, the PLMN and the cell ID. So the cell ID is total 28 bits. So the first 20 bits is inode B ID. This inode B ID is 20. The first 20 bits. The cell ID is 8 bits. The last 8 bits. So from this value, we will know the inode B ID and the cell ID. The cell ID is 1. Is 1. Yes. So under this inode B, this is the first cell, the cell 1. Under this inode B is cell 1, and you can change it. This is the bit stream. You can change it to the number. We can use the calculator to change it. That's too much. I cannot calculate it. So we can get it. We can get this value.
Binary.
Yeah, this is inode B ID. So when you trace the signaling in the UE side. When you trace the signaling in the UE side, you find that there is some abnormal. So how to know this UE now belongs to which node B, belongs to which cell? You want to check the cell's parameter. Okay, by this value, ECGR. This information contained in the initial UE message. It will contain this cell ID, and also it will tell the MME the cost, the establishment cost. Okay, this is the information we tell the MME. When the MME receives the initial UE message, if the MME have already performed authentication and the UE performed authentication for the MME is okay, it will send the initial contact setup request. So during the initial UE message and initial contact setup request here, it should have the NAS layer. The NAS layer information is only contains NAS signaling. There is no RC signaling. So it should have the authentication. So how the MME authenticates the UE and how the UE authenticates the MME, how to identify each other, we will have the cipher case system. So the MME, it doesn't have the keys. The keys are in the HSS. When we sort out one SIM card, this SIM card have already stored in the HSS, right? It have already in the HSS. So the HSS, it will have the SIM card information. And also in the SIM card, it also have a authentication algorithm. So it will keep this one, this case. This is the basement. In HSS, in the org center, it will have this value. And in our SIM card, it also will have this value. So use the, let me check whether it, no. Use the algorithm. It will generate a CKIK. And use the UE and HSS. It use the CKIK. It will generate the KASME. This is the base to generate different case for different protection. So because this is very important, so we will not use the other interface to deliver it. So it will generate it in the UE side and in the EPC side. They two have the same information, so we'll generate the same one. It can communicate with each other. So if the SIM card is a normal SIM card, so they can generate this value. So this is for the KASME. This is generated by HSS. So when the MME received the initial UE message, the MME will send a request to HSS to ask for the KASME, to ask for the authentication parameters. The authentication vectors in LTE we have four. One is a random value. This random value we will send to the UE. And this is AUTN. We use this, the node B, the UE. The UE authenticates the MME will buy this value. The XRES, this value is the MME to authenticate the UE. And the KASME, this value is to generate the different case. So when the MME send the authentication letter request to the HSS will generate the vectors and it will send to MME. When MME receives these vectors, it will send the authentication request to the UE side. So we generate 4 vectors, but we only send 3 vectors to the UE. One is random, one is AUTM, one is KSR ASME. It's not the KASME. Okay, it's just to use this value. We can think it can represent the KASME, but it's different. So even someone they steal this value, it doesn't matter. It doesn't matter. So for this random value is that we will send this value to the UE side. UE will, according to this value, to generate 1 RES. UE use this random value to generate 1 RES. This RES, it will send to MME if same with the XRES. If it's same with XRES, that means, okay, this UE is okay. The MME is authenticated the UE. The UE is okay. And we also send the AUTN to the UE. We send the AUTN to the UE. When the UE received the AUTN, the UE also have an AUTN. If it's same, okay. The UE guarantee the MME is okay. We can make sure MME is okay. This is the authentication. So after authentication, it will activate the next layer security. So the next layer security is based on this case. By this case, it will activate the next layer security. So if the next layer security and the authentication is finished, it will send the initial context setup request. That's UE have already guaranteed the MME. MME also guarantee the UE. Both are normal. So now we can create the S1 connection. We can create the barrier. So usually in the inaudible side, because that is the next layer signaling, we cannot decode it. So it's not show it here. So if we can receive the initial UE message and also we received the request, that means the MME and the UE both are okay. So in the context setup, it contains some information. Here, it generates 1 MME UE S1 API ID. So its generator is here, 370. Okay, so next time, when we need to transmit the S1 signalings, it will add this 2 ID. Now when MME give it a feedback, it contains the MME UE S1 API ID. It also will contain the inaudible UE S1 API ID. These 2 ID is one pair. It will always transmit it together. So this is the ID. So when we want to set up the UE context, also we need to create the barrier. So the first default barrier, we said the default barrier is 9 GBR. Yes, do you remember the 9 GBR QoS parameter? It have a AMBR. Yes, it have a AMBR. The AMBR is here, the UE aggregate maximum bit rate. The UE aggregate maximum bit rate. It contains the downlink and the uplink. You can check what's this parameter, what's this value. You set in your network, what's this value. You set downlink and uplink are same value or different?
Back to the side is signaling trace.
Which signaling?
Before. No, we want to know regarding the from signal test during the UE test. UE will send the key from this flow. Yes.
This one?
Yes.
The authentication?
During this authentication, UE will send this key to the MME and then random to MME. So after that, MME will send included the authentication. From this other where this trace, we want to know UE will send the key and MME will replay with the authentication.
This value is not delivered from MME to UE. It will generate by itself. UE will generate one. And HSS will implement. You can see that the first value is saved in the SIM card and the Oxenter. So the Oxenter, they two both have the same key. And the UE will according to this key, and the HSS according to this key. They will generate the CK, RK, and generate a KASME. HSS generates one, UE generates one, because the base they are same. So this value also same.
Okay. Yes, the must be shared between the UE and data from MME and this compare. After it's same okay. But I want to know regarding what the authentication is said by MME from this signal trace.
Here is this one. This one is only the cipher key. The cipher key that when we perform the ciphering and the integrity, we generate by this. So okay, I introduce it again. So first, how to generate the cipher key and the integrity key, and then how to authenticate each other. So first, at the Oxenter and the USIM card, they have a key. They use this key, use the same algorithm. They can generate the CK and IK. The CK and IK deliver to the UE and HSS. Your SIM card is in UE side. Oxender is in HSS side, inside. Yes? So we can think they are together. So they can generate a KASME, this value. So this value, it will generate the nuclear security key and the nuclear integrity key. So this is one for security, one for integrity. And here, from this one, it can generate inode B key. For inode B, it will generate the user plane ciphered and the control plane ciphered and integrated. So this value is both in the UE side and MME side. So we can generate several different. So how we use the same one? So the MME will deliver to the inode B side. So that value, we can see that here, that value is generated in the HSS. So it's HSS tell MME, you should use which one. Yes? So first the MME will send an authentication data request to the HSS. When the MME received the initial UE message, we should perform the authentication. Yes? We should perform the authentication. So I will first ask for HSS get the authentication data. So I send this request, and HSS will give me these vectors. The vectors contains four parts. The red value, the LTN value, XRES value, and the KASME. Now MME get the KASME. This value used for the cipher system. Other value For the rand value, AUTN and XRES used for authentication. So now, just MME received from HSS. Now I need take authentication with UE side, right? I need to send it to UE. So which one we will send to UE? Which one? I will send the UE the rand value, the AUTN value, and the KSI ASME value. This value is different. The KSI ASME is different with the KASME because KASME is very, very important. If I deliver it by the air interface, it may be stored by others. So I use you can think the KSI ASME is an identity ID. The UE can from this one get the real KASME.
Okay, from the flow, MME will be sent authentication to this UE. User identification request including a random authentication and KSI. Okay. From the flow, if we compare the signaling trace, there is information or not from the signaling trace regarding this request.
All these signalings between the UE and MME is the next layer signaling. The next layer signaling we call it is the UL information transfer. And the uplink information transport. And also downlink information transfer and the downlink info transport. When you trace the signaling, you will see these four signalings. If you use decoder to decode the information, it will be like this. So this is the signaling you traced by the air interface. This is we decode it. The real is this one, the user authentication request. But when you see it, it's the downlink info transport and the downlink info transfer. And when the UE reports the user authentication response, actually it should be the uplink info transfer and uplink info transport. Different description, but the information are same because this is the not signaling. InnoDB cannot decode it. Only UE can decode it and MME decode it. So this is the signaling. So in this value, the MME will by this signaling delivered to the MME by UE, delivered to UE decode it. And the UE receive this value. When the UE receives the AUTN, this value also in UE side. UE also will generate AUTN. If MME is sent to me, it's same with mine. I can authenticate it. I think MME is okay. And the UE side will use this rand value to calculate one value is RES. Use rand value, it can use the algorithm to calculate one RES. And it will report this value to MME. MME will compare the RES with the XRES. If this value, these two values are same, that means the UE is normal. This is authentication. So now we just to authenticate each other, both way two are normal. Now we need to activate the security, the next layer security. So also for next layer security is also this signaling. The signaling just to communicate, okay. To communicate which one? To communicate this one. Which key we use? For security, active security command, okay, we need to use this key for integrity. We use this key for the ciphering. And if this finished, we need active AS. We need active AS security, right? We need active security. So if we finish the next layer authentication and the next layer security, that means we can create an S1 connection. So okay, the MME will transmit the UE contact setup request. Yes, it will send this next request to the node B. It will contain this information to the node B. Let the node B can perform the AS security. It will contain this part. So now, how many information contained in this initial contact setup request? Okay, I wrote down here. All the signal means we wrote down here. So initial contact setup, yes? No, we have already checked it. Two information. In this signaling, okay, MME generates this ID, and it will send it to the node B. Now that ID we have already addressed there, and we need to create the barrier. For the first barrier I said is the default barrier. Yes, the default barrier we have one parameter is the AMBR. Yes, the aggregated maximum bit rate. So here is the AMBR. These two values. One for downlink, one for uplink. You can check in your system which value you set. This is decided by the EPC side, not by not by the node B side. It's EPC decide, okay, how many resources for you.
People build IMBR and non-IMBR is setting in MME or setting in node B.
Which one in node B?
No, because full UA are given maximum bit rate IMBR. For the downlink, this 1000 and uplink is 5000 something. This data, the setting from MME or setting in node B.
You first answer me one question. This value is this signaling from where? This signaling from where? So this data who configure? Okay. Yeah, this signaling from MME. So this is node B receive it. You tell me how to configure it. Yes. So MME send this signaling to the node B side. So node B will according to this value to decide how to create this barrier. So when we read these parameters, please know, okay, it belongs to which signaling, okay? I have already written here. You also can write it down. You can also write it down, okay? This is the first parameter it contains, the AMBR. Now we need to create the ERAB. This ERAB we have different. We may create many different ERAB. We may create many different barriers. So each barrier we need to give it one ID. Give it one ID to indicate it. So the first ID we create, the barrier it can. The ID it can from 1 to 15. So for default barrier we will start it from 5. So the first default barrier will use 5. The ERAB ID is 5. This is the barrier ID, not QoS parameters, just to indicate this barrier. So next time we will create the QCI 5. So its ID is 6. So next time we will create the QCI 1. Okay, its ID is 7. Just one ID, not QoS parameters. The ERAB ID. No. Next is the ERAB level QoS parameters. ERAB level QoS parameters. So the QCI we create is none. the QCI we create is none. So it will contain A and BR. It contains the QCI, right? So how to create this barrier? So you create a QCI none barrier. And it will have the allocation retention priority. Allocation retention priority, that yesterday I said we have one ARP. That is when the resource is okay, which U is barrier can first set up. This is the priority level. And it contains two parts. One is the pre-ampersion capability, one pre-ampersion vulnerability. So these two. That is, how about my barrier? If the resource is limited, is I to grab others' barrier or others to allocate my resource? It decides here. And the transport layer address. So for this barrier, is it not be communicated with SGW? Yes. So this address is the SGW address. That means next time you need to create a barrier. This barrier destination, where is destination? So when we check the signaling, sometimes if there is no alarms, but the service, we cannot do service. When you check the signaling, you can check this transport layer address. This address is the SGW address. If this address we configured is not the real SGW address, so you cannot go to the SGW, you cannot transmit the data. So for example, the EPC side, the SGW is down. But they don't tell us and they don't change it. They don't change this parameter. So it also allocates the down SGW to us. So we cannot do service. So when you check the barrier, the transport layer, you check this address. The transport layer address is the SGW IP. This is SGW IP. You can change this value.
You said 9, in your case, it's a default mirror. You say 9. That's the default mirror.
That's which one? The Q, you said.
That's your default mirror. That's your default mirror.
Default mirror.
Default barrier. You have the signaling. You can.
I can only open the. I think it's only in a PNU and.
Yeah, it's okay. I just want this one. Let me check what's.
My server is down.
Okay. So this default. We will create different PDN connectivity. Aside for PTW, it will have different APN. We will connect with different APN. For each APN is a PDN connectivity. So for every PDN connectivity, it will create one default barrier. So we have two APN. So we will create two default barriers. This is the first one. The first default barrier we created is QCI9 or maybe 8. It is okay. It doesn't matter. They are used same QoS parameters. QCI9 is the first default. Even we have 40, we also will first create the QCI9, and then we will create the QCI5, because they are belongs to different APN. Belongs to different
So
APN.
you mean there's two portable here, PCI 9 and 5? Or
We first create the QCI9 is for the internet. Now we create the internet PDN connectivity. And after that, when we finish this barrier, we have we have created the QCI5 for RMS, for VoLTE. When we create barrier, we will create one by one. We cannot create two barriers at the same time. We will not create the same barrier at the same time. So we will first, this is the first we create. This is the second we create. So now, we first create this one. And when we finish this one, if we have VoLTE, we will create the second one. Okay?
only for the second PCI 5, with all these default or dedicated barrier?
QCI5 is also default. It's also default because it's in the MS, in this PDN connectivity, is the first. It's the first barrier. The first barrier is default barrier. For when we make a vertical except QCI5, we also will create the QCI1. This is dedicated. For 9 and 5, these two are the default because they belong to different APN.
Different IPN.
Yeah, for every APN, the first barrier is default. For QCI9, it belongs to internet, it's default. For QCI5, it belongs to RMS, it's also default because the PDN connectivity are different. They are both use the default, but the default the QoS parameters are different. We give the QCI5 is a higher priority. So we have two connectivity, PDN connectivity. We have two barriers. But when we need to service, okay, we first let QCI5. We first give QCI5.
Kalau beli mobil ya.
Yesterday you're going to listen to me. Okay. The question is, yesterday we introduced a QCI table. Yes, we introduced a QCI table. And that we said that is QoS parameter. And here also the QoS parameters. Right? What's the difference these two? They are same or not? In the table, we have the QCI parameters.
As per your slide, different.
Same.
Okay, in this table, what is QCI? What is QCI? Here. So every QCI it will relate to the exact parameters. It's fixed. So I don't tell you, I don't attach, accept. And the next is the UE security capabilities. UE security capabilities. It said in this NAS PDU, in the RC connection complete, in this PDU, we will report the UE security capability to MME, and the MME will tell Inode B. And in node B, we'll query the UE radio capability. Yes, they will introduce the UE capabilities. So here, next is the UE security capabilities. That is, the MME should tell in node B next the encryption algorithm you should use and the integrity protection algorithm you should use. So it's the MME tell in node B, just like this one. This one is MME delivered to node B by this message, initial context setup request. It will contain the security. So this in node B side, we received this value, then we finish. Now we finish the S1 connection. Now for the first part, second part, we have already finished. Next is the third one. We have already get the security parameters, right? Now we should active the AS security. And the node B only receives the UE security capability. He also need to know the UE radio capability. So it will query the UE.
Question. This security information we use only for the specific mirror or for all mirror that we created?
All.
All.
Not only for barriers. That security is for all the barriers and the signalings. All the information, if we need separate or we need to give it integrity protection, we will use that. Okay, about the S1 connection, any question? S1 connection.
So for S1 connection message, is it can be read by UE? Can be traced in UE side or
You said which information process
for S1?
S1.
All S1.
S1. S1 signaling, S1 connection is between the node B and MME.
Yeah.
Yes. So it's only processed by node B and MME.
Cannot be traced in UE side.
Yes. For S1, it only exists in the MME and node B. So node B and MME process it. UE cannot process this information. So just some information, if in this value in the S1 it contains the NAS layer, okay, it will deliver to UE, process it. If there is no NAS, okay, it's node B and MME process it. When UE will process it, it decides by the signaling information whether it contains the NAS.
Okay.
For S1. Are you clear?
So for the second default mirror, so when will be added after this one?
When we finish this part, when we finish the attach, when we finish the total attach procedure, it will start the second. Yeah.
Is it triggered by when I want to connect 40 or no?
When this finished, I will show you. No, attach is not finished. When attach is finished, it will start the second. Now the attach is not finished. It's only created as the RC and S1. We are not even creating the barrier. Yeah, we just know how to create the barrier parameters, but we even not create it. So the node B will query the UE capability. It will send a UE capability query. Yeah. Okay, I will request your LTE capability. I will query your G1, and I will carry out CDMA, and this is decided by the InnoB whether which rat it support. It will ask the UE this information, and the UE will report it. UE capability information. The UE will report it. Okay, my capability. Here is the system. It support. So I repeat. It indicates one feature. I repeat. It indicates one feature. So the bit sequence is defined by the protocol. UE just to report 0 when you decode this. It will change to 0 or 1, 0 or 1. If 0, that means I cannot support that feature. If 1, that means I could support that feature. So when the InnoB receives it, it will know which you can support, which feature you cannot support. And for the U-turn, here the LTE capability, this UE, it supports the release 8. You know, the 3GPP, it has many different version protocols. Release 8, release 9, release 10, release 11 like this. So it only supports release 8.
Wait, backside. Backside. Regarding UE capability, InnoB will send the how many UE capability in this?
How many UE capability?
No, before there is trace, InnoB will send this UE capability. I think there is 4 or 3. 4.
No, hey, InnoB will first query the UE capability. I want you to report your in last signaling. Okay, I ask you LTE capability. I ask you G1 as GSM for CS and PS capability, and I ask you the CDMA 2000 capability. Ask you these 3. So this is a report. Okay, for different capabilities, it will report to the InnoB side. So here is the container. It contains how many capabilities it can support. It's not only LTE side. It contains all. This is the container. It contains all the capabilities.
Okay, this is report from UE to InnoB, right?
Yes.
Okay. From this data, with the capability UE, this is MP, LTE, GSM, from where we know regarding from this signal.
If you want to know, you need to check the
Yes.
protocol. You need first change it. We don't need to decode this because next it have already decoded. It's already decoded. Here is just you. Okay, in my container I contain so many. Okay, I can decode some for you.
Okay, no problem. Because from this data we can decode. We want to know regarding the UE capability. Yeah. Okay.
Yes, we can know it.
Okay.
For the user capability. Okay, the category is 3. The release version it can support is 8, and it cannot support the RLHC. And the physical layer, the RF parameters, that is which band it can support. Okay, band 2, band 4, band 5, band 12, like this. This is the measure parameters. How many interfrequency band you can perform. Okay, like these parameters. The features in LTE, the features you can support which one. Okay, here the uplink grant like this for different the intra subframe hopping. Okay, it cannot support the frequency hopping like this. you will know, okay, which feature it will support, which feature it cannot support. So, for example, the TTI bundling cannot support. The SPS scheduling, it cannot support. Between FDD and TDD, it cannot support. So it's a very, very old UE.
So what kind of the type
It's a very old UE.
promoting?
Yeah. So you will know.
Rolex bisa.
Maybe okay.
So it's a very, very old.
I see.
Nubia bu.
So it's almost for 1 is support, 0 is cannot support. So you will know.
Cannot support it.
Yeah. So the node B will know. Okay, you cannot support TDD and FDD. Yes, you cannot support the handover. So you only stay at 1. It only support the FDD frequency. So you only display in the FDD frequency. Yes. So from this information, from the UE capability information, the node B will know the UE information, and it will also to report to the node B to the MME side. Okay, so this is the UE capability information, and the UE capability info indication is to report to MME side. Report to MME side. So the UE capability inquiry and the security mode command, these two messages usually sent to the UE at the same time. Okay, you want to first take a break. Okay. Next we introduce the third and the fourth part.
So Nubia okay or not?
Nubia is okay.
Are you
You
using
find
Nubia?
noise.
But you are using Xiaomi, right?
I use Xiaomi. Nubia is ZTE is passive for me.
Xiaomi is more.